Okay, let's go ahead and begin and let's take a look at roots, zeros, and factors of a polynomial. Now let's go ahead and just say, for example, that we have f of x is equal to x squared minus 4. Then what we can do is we can always go ahead and take this polynomial and rewrite it as a multiplication of various linear factors. So in this case, of course, we know that this is just going to be x plus 2, x minus 2. And those would be the factors of this particular polynomial, which we know is a quadratic. Now, if f of x is equal to 0, then of course by the zero product property, we know that x plus 2 is equal to 0 or x minus 2 is equal to 0. And therefore x is equal to negative 2 or x is equal to 2. Now what these are going to be called, they're going to be called the zeros or roots of the polynomial. Now, if we go ahead and take a look at what this graph looks like, again, we know that it's going to look like a quadratic as such. Now notice that the x-intercepts of the graph are going to be the roots or the zeros, only if the root is real. Okay? Of course, if the root is not real, then it's not going to show up here as an x-intercept because, of course, the Cartesian coordinate system is based only upon real numbers. Okay, so that's the relationship between factors, zeros, roots, and the x-intercepts of the graph if the root is 0, if the root is real. Now, when it comes to some of the problems that we're going to have to deal with, we're going to have to take a look at three specific things. The first one is, given a polynomial, how do you find all the roots or the zeros? Well, we just described it here. If you can get it into the product of linear factors, then we can use the zero product property to come up with all the zeros and roots of a particular polynomial. Now, if we are given the roots, how do you find the original polynomial? Well, basically the procedure is go backwards from what we did here in number 1. So say, for example, if you know that these are roots, well, then that means that x plus 2 and x minus 2 has to be equal to 0. And if you go ahead and multiply those two together, then you'll be able to come up with the factored form of the function. And then, of course, when you go ahead and multiply that out, you can come up with something, in this case, which looks like x squared minus 4. Now, the one thing that we need to be careful about, though, is that this is only one particular form, or one particular quadratic function, that is actually going to have the roots of negative 2 and 2. What we need to be careful of is that we need to go ahead and also multiply by a parameter a, for a not being equal to 0. And so the answer for this particular question, given the roots x is equal to negative 2 and x is equal to 2, would actually look like this. F of x is equal to a times the quantity x squared minus 4, where a is not equal to 0. Now what does that mean? Well, that means basically that if we go ahead and take a look at any of those families of functions, or any of those functions within that family, given the parameter a, then what's going to happen then is you're just going to have a vertical stretch or shrink, but what will always remain constant is that your roots are going to be both negative 2 and 2. So we just need to be careful about that one parameter to encompass all the family of functions which have those particular roots. Now, the last thing that we'll also take a look at is polynomial equality. And I think it's going to be very commonplace, very common knowledge, I think, to understand exactly how we can make sure that two polynomials are equal to each other and how to distinguish between those polynomials that are equal to each other and those that are not. We can say that two polynomials are equal if and only if their degree and corresponding coefficients are the same. So say, for example, we have 2x squared plus 4x plus 5 is equal to ax squared plus the quantity 2b minus 6x plus c. Well, what we have to do, being that we know that the degree is the same, we can just go ahead then and equate the coefficients, and we can find out what the values of a, b, and c are. Okay, so just to wrap up again, when we take a look at the roots, the zeros, and the factors of the polynomial, we're talking about very connected things. The factored form of a particular polynomial will then be able to yield the zeros or the roots, which will then be able to be graphed as the x-intercept of the graph so long as the roots are real. Now, if we're given a polynomial, how do you find all of those roots and zeros? Well, of course, we need to go ahead and factor the polynomial into linear factors. If we're given the roots, how do you find the polynomial? Well, we just go with a reverse process of finding the roots and the zeros. But then the one thing that we need to be careful of is multiplying by the parameter a so that we deal with the whole family of functions which have those factors or roots. those roots are zeros. And then lastly, in order to go ahead and show that two polynomials are equal, we need to show that the polynomials first of all have the same degree, and then the corresponding coefficients are going to be also equal. Okay, and so there you go. That's basically what this particular section is all about, and we'll take some questions from you later the next time that we meet. See you later. Bye-bye.